Can we go back to the indefinite integral?
Anything you want.
Okay. So x cubed times the square root of x squared plus 23 dx.
Good. What is the problem here?
The square root of x squared plus 23?
No, not in this case.
No?
No. This is the outer function. The problem is the inner function.
Oh, so just what's under the radical, not the radicals.
Yep. So this is 2x dx. Okay, the 2 is not a problem. Multiplying by 2 and dividing by 2 never created a problem. I have 1/2. I have the integral from, there is an x cubed here, which I have to borrow from it. I have to borrow an x, and I will have an x squared left over. So I borrow the 2, I have the 2, and I borrow an x because I need 2x dx.
Yeah.
I have the square root of u, or u to 1/2. But I have a leftover of x squared. Do not copy x squared here. That will be a terrible mistake.
Because you can only have u.
Exactly. So from here,
would it be like u minus 23?
U minus 23. So please remember, from integral in x to an integral in u, no leftovers. Everything has to be accounted for. And the way we deal with x to the third,
we break it up.
You have to break it up because we need an x for du, and the x squared is easy to be determined from here, u minus 23. Next, 1/2 in front, I have to distribute. U to power 1 plus 1/2 is u to 3/2. Minus 23, u to 1/2 du. Now this is a piece of cake. 1/2 u to 5/2 over 5/2 minus 23 u to 3/2 over 3/2 plus a constant c. Flip and get 1/5. Replace u by x squared plus 23 to 5/2. Flip minus 46 over 3, x squared plus 23 to 3/2 plus a constant c.
And we would enter it as is, like that?
Yes, it's horrible. Yes.
Yes.
Don't ask me how you enter it. So you have 1/5 and then x squared plus 23, and the power is 5/2. And then minus 46 over 3. And parentheses, x squared plus 23 to 3/2. And don't forget the constant c.
Yes.
Good.
Let's see. Oh, shoot, I forgot a power. Oh, I've got to wait for it to tell me it's wrong. There we go. I forgot the 3/2 in the exponent.
So remember, we spent an entire class on 5.2. Please go back to those problems and practice with them.
It's marking it wrong. Can I show you what I
entered? Yes, please.
Did you catch anything?
Yes.
Okay. Can you see that? So I'm looking over 5 halves.
So you have 1/5.
Sorry, not 5 halves. 1/5 x squared plus 20.
It may not like parentheses for the powers.
It automatically defaults to that, though. I didn't put them there. As soon as I type a fraction bar in the parentheses, in the exponent, the parentheses appear. I didn't try and get rid of them.
Oh, I know what I did. I just saw it. So here's what I did. Sorry. If you want to stop sharing for a second, Amanda. My fault.
Oh, yeah. Sorry.
So here's what I did. I distributed 1/2 here. But I was supposed to distribute 1/2 here as well.
To the 23, yeah.
So when I flip
that.
It's just 23. It's just 23 over 3. Sorry about that. My fault. If it doesn't give you the points, I'll give it to you.
It should still.
So 46.
No, 20.
It should be 23 over 3.
Yeah, I have that now. So then what? Because it's minus. Did I put a plus? No, I have it as minus 23/3. Yeah, it's still marking it wrong. Can I change that?
Yeah, can I see it?
Go back through our steps and see if we missed them.
Can I see it? One plus 1/2. 1/2. 5 halves. 5 halves. 3 halves. Okay. 1/5, that's correct. So see, I'm not sure it wants parentheses for the power. Can you remove the power on 3 halves? The power, the second power? Yeah. Can we try now? And it still doesn't like it. Okay, give me 1 second, let me check. So that's correct. 2x dx. That's correct. Now I'm checking everything. 1/2. We have u minus 23. We have u to 1/2. And we have du. 1/2. We distribute. 1 plus 1/2 is 3 halves. 23 u to 1/2 du. 1/2 in front. U to 5 halves over 5 halves. That's correct. Minus 23 over 2. U to 1/2 plus 1. 3 halves. 3 halves plus a constant c. Did you put the constant lowercase c or uppercase c?
I have it uppercase, which is how it asks it to be, and that's how I entered it for other answers.
Good. Okay. So when I flip 2 over 5, that's 1/5. 5 halves. You enter 5 halves for the first one, right? Yep. Minus, I have 23 over 2 times 2 over 3. It's 23 over 3. X squared plus 23 and power 3 halves plus a constant c. I don't see any problem.
My only other thought is it wants me to distribute and get rid of those 2 sets of parentheses. I don't know why.
I'm pretty sure it would automatically do that.
Yeah, so I'm not sure why. Sometimes it can be finicky with how it wants you to answer it.
Can you delete it, the whole thing and start from scratch one more time?
Retype it?
Uh-huh.
Yeah.
You'll get the point. So 1 over 5. Open. X squared plus 23, close, power 5 over 2. Okay, okay, that's fine. Down, minus 23 over 3. X squared plus 23. And now the power 3 over 2. And then plus c.
Hold on, I think I might have found my issue. Let me see. And we just didn't catch it. So when because I have written down for this second term, I have x cubed written down for some reason and not squared. I must have had a 3 there and we
Okay.
didn't catch it.
Yeah, because there is nothing else. We checked everything. Good, awesome. Anything else? Good. I'm glad. I'm glad I said let's do it again. So when that happens and it repeats, just do it again. Enter it again. Is there anything else from 5.5? Anything else? I didn't see a power 3 in there, actually, to be honest. I think it was just going on the same loop or something. Okay. Other problems? Anyone? Amanda? Anything? Other problems you need help with? Anything else?
From any section. I'm feeling pretty good. Definitely feel better about the definite integrals than the indefinite, but getting there.
Well, they're basically the same. We just have to go back and replace. This is easier because you don't have to do the arithmetic. You don't have to plug in numbers.
Sometimes I like when it just comes out to a nice number.
Oh, okay. Good. So then we can move on to another section or another topic, or are we done with this? Okay, so this is done. Derivative of a function given in a form of an integral. Would you like to choose one? Or I will.
What subtopic or subsection?
This is part 1.
So 5.1?
No. This is part 1 of Fundamental Theorem of Calculus.
Oh, gotcha.
And
So
that is in
5.1.
section 5.3. We had something for homework today.
I've got one.
Okay, I'm ready.
So it's use part 1 to find the derivative.
Yes.
So f of x equals, right, and then it's from x to 0. The square root of 6 plus secant 4t dt.
Perfect. So
and then it says int. I don't know. It's telling us. I think.
So first of all,
negative.
in order to apply the fundamental theorem of calculus part 1, the lower limit has to be a number. So by swapping the limits of integration, we fulfill that requirement. And now we're ready to differentiate. We're differentiating this, and we're differentiating this. All we need to do here is copy the negative sign and replace, since x is the plain simple x, it's not a function, it's a function, but it's the plain x. X prime will be 1. All we need to do is just write 6 plus secant 4x. I should write times the inner function prime. This is the inner function. But I don't write it because this is 1. That's it. Finding the derivative of a function given in the form of an integral. Should we choose another? Please remember to check all the written solutions for homework. They're all posted for 4.9 through 5.5.
It's marking it wrong. 6 plus.
Did you put the negative in front?
Uh-huh.
You put this
I'm gonna try erasing it and typing it again. So negative square root.
Yes.
6 plus secant.
He may ask you what parentheses for around 4x. I don't know.
Oh, I put a t instead of an x, I think.
No, I have to have x because it's f prime of x.
Because it's f of x. Yeah. Nope, that was my mistake.
Good. Would you like to work on another?
Can we work on?
I'm ready.
Can we work on 15 of 5.5?
Yes, ready.
It's just indefinite integral of x times 2x plus 7 power of 8.
X times 2x.
X parentheses 2x plus 7, and that's the power 8 dx.
Good. So the problem is this.
Yeah.
So du equals 2 dx. 2 with dx accounted for. How come that I don't have more colors here? So 2 with dx are accounted for in du. This is u to the 8th. And no leftovers. I have a leftover. Move 7, divided by 2.
I see.
No leftovers. Not allowed. So then, 1/2 outside. Again, make sure we account for everything. 2 with dx. U to the 8. X, u minus 7 over 2. Everything accounted for. Therefore, I take the 2 outside. I distribute u to the 8 minus 7 u to the 8 du. U to the 10th over 10 minus 7 u to the 9th over 9 plus a constant c. I'll distribute 1 over 40 2x plus 7 minus, don't forget to distribute to both like I did a few minutes ago. 1/4 times 10, 4 times 10, 4 times 9, 36, and 2x plus 7 to the 9th plus a constant c. Please remember, no leftovers. No integral in this class has 2 variables in it. They exist, but they are double and triple integrals. That's Calc 3.